Okay, so we're moving into the next section of dealing with systems of equations with 3 equations and 3 unknowns. Now, when we had 2 equations and 2 unknowns, we had 3 choices of methods to solve. We could graph, we could use the substitution, or we could use the elimination method. Now, we could do that with these as well. We could graph these. Yeah, I don't recommend it because you need the x-axis, the y-axis, and a z-axis, which is a front and back axis. So now you got to think 3-dimensionally. Yeah, most of us aren't as adept to that as we would like to be. We could use substitution, but if you're not careful with the substitution method, you could really get yourself spinning in a circle and really never find the answer. So my recommendation is to use the elimination method. Now, here's how I'm going to make it a little bit simpler for us to communicate. I'm going to number these equations. I have 3 equations. So equation 1, 2, and 3. Now, just like the elimination method, when there's 2 equations and 2 unknowns, I have to make certain that all 3 equations are in the proper format. All the variables on one side in alphabetical order, and all the terms that don't have a variable are on the other side. Is that true? Good. So the equations are set up just fine. The other thing I have to do, or the next thing I need to do, is actually pick a variable to eliminate. The choice is yours, whichever you think is the easiest variable to eliminate, x, y, or z. Me personally, I'm going for the y's. You're like, I want x, I want z. Well, that's fine. You do this, picking x or z if that's what you choose. I'm going to pick the y. All right, so now here's the deal. I have to eliminate y out of all 3 equations. But my brain doesn't handle 3 numbers at a time. So it's not going to handle 3 equations at a time. You're like, what do you mean? Okay, so sidetrack. I always get us back on point, so hold on. I'd like you to add the numbers 5, 6, and 2. What'd you get? Okay, now that you have that answer, I need you to think about how you got it. First thing you did, yeah, you added 5 and 6, and you got 11. So you took the first 2 numbers, added it to get 1 number, and then you took this 1 number and added it to the 3rd number, didn't you? So you still only added 2 numbers, 11 and 2, and got 13. That's why I can only take 2 equations at a time, because my brain only works with 2 numbers at a time. So me personally, I am going to choose equations 1 and 2 to work with. And I need, remember, this is the elimination method. You need the variable in front of the y's to be exactly the same but opposite signs. So, good. Equation 1 needs to change, doesn't it? Yes, and I need to take equation 1 and do what to it? Multiply by, yeah, -4. So this is how I write my work. I'm going to put down that -4 next to the 1, so I know I'm multiplying equation 1 by a -4. And when you do that, what do you get? Yeah, you get -4x minus 4y minus 4z equals -40. Good. Am I doing anything to equation 2? No, not multiplying it by anything. So we have 2x plus 4y plus 2z equals 24. And then, yeah, we add the 2 equations together, right? That's why sometimes the elimination method is also known as the addition method. Okay, let's add. So we get a -2x. The y's cancel. Yay, that's what we wanted. We get a -2z, excuse me. See, that's why you needed doing with me, I heard you. And then, good, we get a -16. Cool? Okay. Now, I eliminated the y's from equations 1 and 2, but I also need to eliminate the y from equation 2 and 3. The choice is mine, okay? I'm going to take equation 3, and I'm going to take it with equation 1. You're like, why can't I do one of the other ones? You can. Be my guest. So I'm going to take equations 1 and 3. and I need the coefficient of the y to be exactly the same. Yeah, so what are you going to do? Good, equation 1 needs to get multiplied by a -8. All right, let's see what this looks like. So that's a -8x minus 8y minus 8z equals -80. And equation 3 is a -x plus 8y minus 3z equals 0. And then I add. So -9x, the y's drop out, yay, that's what we wanted, minus 11z equals a -80. So check this out. I ended up taking 3 equations and 3 unknowns and reducing it to 2 equations and 2 unknowns. So here's equation 4 and here's equation 5. So now I need to eliminate, right, either x or z. Now you know, I'm noticing equation 4, I can kind of reduce it, can't I? It looks like everything would divide nicely by 2. Don't you agree? So I'm going to do that. I'm going to make my life a little easier because I'm noticing these numbers aren't looking so nice. So I'm going to divide everything in equation 4 by a 2, a -2, which will give me a positive x, a plus z, positive z, equals a positive 8. So this is my equation 4 that I choose to work with instead, because it's just going to be a whole lot nicer to work with this equation 4 and equation 5. All right? Okay. So equation 4 and equation 5. And I have a choice. Eliminate x or z. What do you want to do? X? Okay, we're going for the x's. So let's get rid of the x's in these 2 equations, which means, correct, equation 4 needs to get multiplied by 9. All right, let's see what this looks like. So equation 4 would be 9x plus 9z equals, no calculators, good, 72. Equation 5, we're not doing anything to it. So -9x minus 11z equals -80. X's drop out, yay. -2z equals -8, which means, look at that, z equals 4. Yay! Found one of my answers. Z equals 4. Hurrah! And now I have to do what? Yeah, now I've got to find either x or y. The choice is yours what you want to do. But if you think about this, didn't equations 4 and 5 contain an x and a z? And since I know z, couldn't I use equation 4 or 5 to go find x? Yeah, we could do that. And me personally, I like equation 4, don't you? All right, so using equation number 4, we have x, I'm going to use this one, plus z. Well, since z is 4, I'm going to say x plus 4 equaling 8, which means, yeah, x equals 4. Awesome. So now I have x and z. What do I need? I need y. So how are you going to find the y? Yes, now I'm going to go back to one of these 3. And yeah, I agree with you. Let's choose equation 1, because equation 1 is an extremely simple equation to handle since the coefficients are all 1s, right? Okay. So if I look at equation 1 and I plug in the x and the z, so it says x, so we're going to take 4 plus y plus z, which is this 4, equals 10. And when you do all your work, you end up with y equaling 2, don't you? So I have 3 answers, x, y, and z, don't I? I have an ordered triple. So that order triple gets written in alphabetical order. So X, Y, and Z. And if you remember, since I actually have a solution, this method is considered a consistent and independent system. I actually have a solution. I actually have a point of intersection. These equations don't depend upon each other. That's 4, right? So X, 4 spaces on the X. So I'm going to go right 4 spaces. Y, 2 spaces up for Y, and 4 spaces forward for Z. So if you actually graph them, your point of intersection would be somewhere out here in this space. Yeah, that's something interesting to think about, isn't it? Okay. Recap. 3 equations and 3 unknowns. Eliminated 1 variable. Ended up with 2 equations and 2 unknowns. Eliminated another variable. Ended up with a solution. Took this solution, and now I'm going to go backwards, and I'm going to take this solution and plug it into one of these 2 equations, which gave me a second solution. And then I'm finally going to take these 2 answers and plug it back into one of the originals to get number 3. Does that make sense? Okay, hang in there. Okay, so let's look at the second equation. I have 3 equations again and 3 unknowns. So how do we start? Good, make certain they're all in the correct order. Are they? Excellent. And I am going to number them. Why? Just so it's easier to talk about. So I have equation 1, 2, and 3. Okay. And then you have to pick a variable to eliminate, don't you? So we have X, we have Y, we have Z. How many go for X? How many go for Y? How many go for Z? Z's have it. Okay. So we're going to eliminate the Z's out of all 3 equations. So remember, how many numbers can your brain handle at a time? 2. So I'm only going to take how many equations at a time? 2. Okay. So I don't know about you, but I'm just going to take equations 1 and 2. So remember, since I'm eliminating the Z's, I need the coefficient of the Z's to be exactly the same, but opposite signs. So, yeah, equation 1 needs to get multiplied by a 3. So, equation 1 gets multiplied by a 3. So let's see what equation 1 looks like. So that would be, good, 21x minus 3y plus 3z equals, oh, stay off the calculators. What'd you get? 3 times 144. Yeah, negative 132, right? Agreed? Okay. Equation 2, not doing anything to it. So 3x plus 2y minus 3z equals negative 12. Add them together. 24x. Oh, that's a minus, isn't it? I started writing a plus. See, I heard you. This is why you guys have to do the work with me. Minus y. Z's are dropping out equals, that's right, negative 144. Awesome. Okay, numbers are a little big, but no big deal. Not to panic. We're all right. All right, good? Okay, so we just eliminated the Z's from equations 1 and 2. Ah, yes. Now you got to deal with equation 3. And with equation 3, yeah, I would also take equation 1, because equation 1 has a 1 in front of the Z, which will make it easy to work with. So what do we need to do? Still eliminating the Z's, which means that Z needs a negative 2 in front of it. So I guess I'm taking equation 2 and multiplying by a negative 2. All right, let's see. So equation 1 will become a negative 14x, oh yeah, plus 2y, minus 2z equals positive 88. Equation 3 is x minus 3y plus 2z equals negative 10. Add. All right, negative 13x minus y, yay the z's drop, that was the point, equals a positive 78. How are we doing? Are we agreeing? Good, so am I. Okay, so I took my 3 equations and 3 unknowns and I reduced it to 2 equations and 2 unknowns. So I'm going to label this equation 4 and equation 5. And now, yeah, now they both have x's and y's and we got to figure out which variable we want to get rid of. Yeah, I agree. Get rid of the y's, right? All right. So now we're dealing with equation 4 and equation 5. Okay, what do we have to do? Anything if you're getting rid of the y's? So let me draw my little arrow here so we remember which variable we're getting rid of. Yeah, one of those y's needs to be positive, doesn't it? Does it matter which one? You're right, it doesn't. So, all right, you want to make this one positive? So equation 4 then has to get multiplied by a negative 1. So let's see. That makes that a negative 24x, a positive y, and a positive 144. Equation 5 is a negative 13x, a minus y, and a 78. Add them together. Yeah, that's negative 37x. The y's drop out. Let's see, what do we get here? Was that 222? Yes? Positive, right? Okay. And now you divide. All right, I know you're on your calculators. I'm waiting. Tell me what you get. Good, I heard you. Negative 6? 6? 6? Okay. Yeah, because 6 times 7 is 42. Hold 4. 6 times 3 is 18, plus the 4 is 222. Good job, you guys. Way to go. Are we done? Nope. We still need y, and we still need z. So, which one do you want to find first, y or z? Good. Go back to equation 4 or 5 and find the variable y, right? Find the answer for y since you know x. So which one do you want to work with? 4 or 5? Does it matter? Nope, it doesn't. And I am just going to use, yeah, I'm going to use equation 5, but I'm going to bring it down over here because I got a little more room. So in equation 5, we have negative 13 times a negative 6 minus y equals a positive 78. So 6 times 13, there you go. This is going to be a positive 78 minus y equals 78. Huh? Negative y equals 0. Looks like y equals 0 is my answer for y. Okay, good enough. If that's the way it works out, that's the way it works out, right? And now, go find z. Where? One of these 3 equations. Does it matter which one? Nope, whichever one floats your boat, whichever one you think is easiest. Yeah, I'm going to go with equation 1. Since I'm looking for z, it has a coefficient of 1, so I think it's going to be the easiest out of the 3 for me. So, all right, so in equation 1, we have 7x, so that's 7 times the negative 6, minus y, well, that's just minus 0, plus z, which is what I'm trying to find, equals a negative 44. Okay, so here's a negative 42 plus z equals negative 44. So it looks like z is equal to a negative 2. Did you get the same thing? Awesome. Okay, time to write our order triple. X first, y second, z last. So what kind of system is it? Because I actually have a solution. Yeah, this is a consistent and an independent system. Cool? Does this make sense? Are you getting the hang of it? Good. I got one more for us. So hang. Okay, let's look at this third problem. 3 equations, 3 unknowns. What are we going to do? Good. They're set up correctly. Yes, let's go ahead and number them just so it's easier to talk about. Which variable do you want to eliminate? Was that your question? Well, I want to eliminate the x's. I think those might be easier to eliminate. What about you? Are you okay with that? Okay. So what are we going to do? Good. Let's deal with equations 1 and 2 first. And, all right, we said we're getting rid of the x's, right? Sorry, let me put my little arrow here to remind myself. So what are you going to have to do? Yeah, let's multiply the first equation by a -3. So, let's see what it looks like. So we have -3x minus 15y plus 9z equals, yeah, positive 24. Good? Not doing anything to equation 2. Oh my goodness. Did you guys not catch that? Yeah, that wasn't a -3. I know some of you are saying, but I told you. Okay, hang in there. So it's -6x, right? Because 2 times -3. Sorry about that. See, that's why I need you doing it with me. All right. Second equation is a positive 6x, a positive 15y, a minus 9z equals 18. Add it all together. Wait, drops. Okay, that whole side is 0. 0 equals 42. Does 0 equal 42? Yeah, it doesn't. So, that's not true, right? That's a false statement, isn't it? So since this is a false statement, since this is false, since 0 doesn't equal 42, that means this system is inconsistent. Inconsistent means there's no answer. However, it is still independent. And you're like, well, why is that? Because it's not the exact same equations. If I graph this, I'm not going to get one line right on top of the other. How do I know it? Because that's a false statement. 0 doesn't equal 42, which means all 3 of these lines are different. Even though there's no solution, all 3 lines are different. Okay? They're not going to, all 3 of them are not going to intersect. Cool? Okay. You know, I got space for a 4th problem. I think I'm going to put a 4th problem up here for us. So, don't go anywhere. Let's see. First, I got to open the pen. All right. So, here's my 4th problem. X minus 2y minus z equals 4. Negative x plus 6y minus 3z equals negative 12, and 2x minus 11y plus 5z equals 22. Okay? So, again, I'm going to label them equations 1, 2, and 3. They're all in the right order. I'm going to opt to get rid of the x's. Are you guys okay with that? Do you agree? All right. So, see if you follow along. I'm going to take equations 1 and 2, and I'm just going to add them together. They both have a coefficient of 1, and they're both opposite signs. So, no problem here. No extra work for me to do here. X's drop out. Yay! This becomes 3y minus 4z equals negative 8. Good? Okay. And Yeah, I still need to work with equation 3. I'm going to choose to do equation 3 with equation 2. Like, hey, you usually use equation 1. You're right, I usually do. But equation 2 already has a negative in front of it, so I'm like, all I got to do to equation 2 is actually multiply it by what? Positive 2? So equation 3, 2x minus 11y plus 5z equals 22. Equation 2 times positive 2. Yeah, negative 2x plus 12y. Let's see. I'm sorry. 2 times that. Negative 6z and negative 24 equals. Did I get that straight? Let me do a quick double check. Negative 2x, positive 12, negative 6. Okay, add them together, right? They drop out. Yay! Y, let's see, minus z equals negative 2. Cool? Oh, I can see an error I made. I'm so glad we caught that. But do you agree with this one? Yes. Did you agree with this one? No. Good. I'm glad you don't, because I just saw that my brain divided, not added. Yeah, that should be a 4, shouldn't it? Okay. All right. Are we all in agreement now? Okay, good. So now we have equations 4 and equations 5. So let's do our work over here. Equation 4 and equation 5. What do you get rid of? What do you want to get rid of? You want to get rid of the y's? Okay, let's get rid of the y's, which means multiply equation 5 by a negative 4. So let's see. You're following, right? Okay. Besides, I said see if you follow along. This is 4y minus 4z equals negative 8. There's your equation 4. We said to equation 5, good, multiply by negative 4, which makes it a negative 4y, a positive 4z, and a positive 8. Uh-oh. I got 0 equals 0. Did you? Yeah, we got 0 equals 0. It's like, well, what does that mean? Well, let me ask you something. Does 0 equal 0? Yes, that's a true statement. Since this is a true statement and all the variables dropped out, that means you actually have an infinite number of solutions. Whereas over here, 0 doesn't equal 42, does it? This one is no solution. There are no solutions to this problem over here because 0 doesn't equal 42. And over here, where they all dropped out and you ended up with a true statement, you actually have an infinite number of solutions. And you're like, well, how can that be? This 0 equals 0 tells me not only do you have an infinite number of solutions, it tells me these 3 equations, if you graph them, they're the exact same line. This is actually a dependent system. Dependent means it's the exact same line. And I know that without graphing because I ended up with a statement where all my variables dropped out, but I ended up with a true statement. Whereas over here, all the variables dropped out, but I ended up with a false statement, which tells me there's no solution, which means inconsistent. Independent tells me they're not the same line. Dependent tells me they are the same line. Good? Little refresher on these types of systems. Is this cool? Okay, so hang in there. We got some stories to go over.